Now, what we're going to be doing is applying what you did the past couple days into some real life scenarios. This packet's just notes. You might work on one tomorrow on your own. So here's what this first one says, and we kind of did something like this last semester, but this gets a little bit more intense. I'm going to get a calculator here. So here it goes. It says a cat leaps up into the air with an initial velocity of 12 feet per second to catch a speck of dust. Then it falls back to the floor. Fat cat. How long does a cat remain in the air? So down here you're finding the number of seconds. Now the first thing you do is set up a box. Now the units are always going to be seconds, and then the other unit is feet. And that's with all the problems. So seconds and feet. Now, seconds is my time unit, so that's X, that's the independent unit, and then Y is my feet, and then per, and I label that feet per second. And my feet per second is clearly 12, so it's actually 12 feet. Okay, it's not the percentage, so I'm actually going to draw a graph here. I'm not going to line up the blank times blank to the power equals blank. That's with percents. Okay, and then what happens, but it's not a line either, okay? The cat does not just go up, up, up forever. He's going to go up, and he's going to come back down, okay? That is known as a parabola, P-A-R-A-B-O-L-A. Now, with parabolas, you don't need to do a whole lot. All you need to do is mark where he lands. Now, he lands on the ground, and that's going to be the case on all these. So he lands at 0 feet. And where did he leap from? Well, he leapt from the ground too, so that's also going to be 0 feet. Now you want to circle the one that's over here because that's going to go into your equation. Well, actually they both go into the equation. So he starts from the ground, he ends at the ground. Now I'm going to need a fairly large box to work with my equation here because these parabolas, anytime you have a parabola, you're going to have x to the second power. So I go blank x to the second plus blank x plus blank equals y. Okay, that's what you're going to put. Now, in our first blank, what is pulling this cat towards the ground? The force of gravity. Okay. And in algebra, gravity is always represented with negative 16 x to the second power. And that's going to be on, even though that's not in the problem, that's what gravity is. So we're going to put negative 16 for the x to the second. Now with the x, you go look at your feet per second and you see 12. It's per second, so 12x. Now the third blank is where the cat started from. Now he started at 0 feet, so that means we can just delete this space. Okay. Now the equation is set up. Now the 0 feet from the landing height right here is going to go in for the feet variable, which is y. Okay. So we can just scribble the y out and put 0. It equals 0. So now, forget that this is even a story problem at this point, and you have to just think of yesterday. So you have x to the second. That means there's 2 answers. Go find your 0. It's there, because I put it there. It's set. Okay. So now how many terms do we have? We have 2. 1, 2. So that's the GCF. And then after that, we see if we have a difference of perfect squares, DOPS, okay? Those 2 boxes. Now, on all GCFs here today, you're always going to have that negative 16. So because we have a negative in the front on the very first number, we want to make our GCF negative. Now check for x's. We have x, and make your lines a little longer, okay? So we have x to the second, we have x to the first. So yeah, both the terms have x. So I go x to the first. And then 16 and 12 I punch into my calculator. So 16, comma 12. And I get a GCF of 4. Okay, so that's coming out here. negative 4x to the power of 1. Okay? Now put that in a parentheses, and then negative 4x to the power of 1, negative 4x to the power of 1. So negative 16 divided by negative 4 is 4. And on x, we take 2 minus 1, and that's to the first. And then positive 12 divided by negative 4 is negative 3. Here, look, I'll show you. So minus 3. And then those x powers can just be eliminated. Now, the dots is not possible because I don't even have the x to the second power. It's to the first power. Don't label ABC either, okay? It's just x to the first power, which means that makes this not possible. So I have my F1 and I have my F2. Now take the first powers out and you set each factor equal to 0, okay, because it's equal to 0. So negative 4x could equal 0, or 4 times x minus 3 could equal 0. So I dot and circle, dot and circle. So I divide by negative 4, and that's 0. And then I add 3. So 4 times x equals 3, divide by 4. And I take positive 3 divided by 4, and that's 0.75. Okay, now you're wondering which answer do I put here with the seconds? Put the higher answer, 0.75. So it takes less than 1 full second for the cat to complete his jump. Okay, and you'll need to take notes here before you work on your own. Okay, the next problem. An athlete throws a discus from an initial height of 6 feet with an initial velocity of 46 feet per second. How many seconds is a discus in the air? So it's the same idea. You got your feet and your seconds. Those are always the 2 units. Okay, so seconds is x and feet is going to be y. So it's feet per second. So the feet per second, we have 46 feet per second. Okay, and after I put that down, I'm actually going to cross it out because I don't want to really, that number there bothering me and confusing me. Okay, so it's a parabola. You don't need to write that word if you don't want to. Okay, that's what that is. So it's not a linear equation, it's a parabolic equation. So the discus lands on the ground 0 feet. But it does not start from 0 feet, okay? It starts at 6 feet, okay? So 6 feet is where it starts from, okay? And that's important when I write the equation. Now we want to circle this one, the landing height. Okay, so I know again, blank x to the second plus blank x plus blank equals y. So if we don't know what goes in front of x to the second, that's where gravity comes in. Gravity in algebra is always negative 16x to the second because it's always that force of gravity on Earth. That's always negative 16. You know how like temperature's 98.6 degrees, well gravity's negative 16, okay? Now your x, you look here, the feet per second, that's 46. Now here you look from where you started. This time I started at 6 feet, so I need to fill this in with 6. I can't just cross it off. And then the landing, 0 feet, is what goes into the equation, and it's going to go in for y because y represents feet. So you can just scribble out the y and put 0. Now forget that this is even a story problem. Okay, you know there are 2 answers. And you know we got 3 terms. Extend the lines a little bit so everything's covered. Okay. So 3 terms will be the GCF, and then I will go to my table. Okay, so the GCF, once again, you're always going to do a negative because you're always going to have negative 16 right there. Anytime that front number's negative, you want negative. Now I got x to the second. I've got x to the first, but then I don't have an x, so don't put x, okay? You will not put x. You're not going to put it here or here. Now, go calculate 16, 46, and 6. And I got 2, okay? So I'm going to factor out negative 2, but not with x, okay? You can't do that. Okay, so I divide negative 16 by negative 2, and that's 8. So positive 8, and the x to the second stays. And then I take positive 46 divided by negative 2. I got negative 23, so I put minus 23, x to the first. And then I take positive 6 divided by negative 2, and that's negative 3, so minus 3. Okay, and ignore that. Now with your table, the ABC takes place here, and we take A times C. Positive 8 times negative 3. That's negative 24. So I got negative 24. So that's going to be a minus problem. All of these are going to be minuses on story problems, okay? And you're trying to get to 23, and 23 is negative, okay? So 1 and 24, well, right away, 24 minus 1 is 23. So those are the two factors I roll with. So 23 is negative, meaning 24 is negative. We have a negative up there. It means opposite, so plus 1. Now our A is equal to 8x to the second power. So when I make the 4 parentheses, I want to start with 8x, 8x. And then plus 1 minus 24. Okay, so 8 and 1. That is 1. Okay, so we divide by 1, and that stays 8x plus 1. 8 and 24. So I check out 8 and 24. And that is 8. Okay. So that's going to be 1x minus 3. Now, you want to take your GCF factor, negative 2, down here, but don't label it F because it doesn't have X, okay? These are my F labels, F1, F2, okay? So 8x plus 1 could equal 0, or 1x minus 3 could equal 0. So I dot my x's. Next problem, I'm going to do these over out here somewhere. So I minus 1, minus 1. So 8 dot x equals negative 1. Just show your work wherever you can find it. And we're not dividing by 1. We're dividing the negative 1 by 8. So when I'm taking a smaller number and dividing it by a larger number, I'm going to get a decimal. So negative 0.125. And then I add 3, so 1 times x equals 3, divided by 1. 3 divided by 1 is 3. Now the higher answer, a positive is always higher than a negative, so I put the positive answer right there, so it takes 3 seconds. You have to, it takes a while to get used to this, so don't just give up on me here. Okay, a baseball is hit into the air with an initial height of 4 feet and a velocity of 30 feet per second. For how many seconds is it in the air? So my units are feet and seconds. So the x is my seconds and the feet is my y. So per feet per second. And that's going to be 30 feet per second. Okay. So cross out 30. You don't want to deal with that anymore after you have it. You're going to put in the equation, but I already have it here. I don't need it in the problem. I don't need it confusing me. Okay, and again, we know what a baseball does. It doesn't just go up forever. It comes up and then it comes back down. Okay, so that's a parabola. So with parabolas, we want to find out where it begins and where it ends. So it's going to end at 0 feet, and that because it's going to land on the ground. No one's going to catch it. So unless I tell you differently, you're going to put 0 feet. But it didn't start from 0 feet. It was hit at 4 feet, so it's going to be 4 feet. So we need a big box to work with parabolas. So blank x to the second plus blank x plus blank equals y. Okay. So again, what's pulling this? The force of gravity is what's pulling this ball back to the ground. Okay. You've heard of the phrase, what comes up comes down. Well, that's gravity. And I always use -16 to represent the force of gravity. Now the x, you look over here, that's per second, so 30x. Now here, look up where the initial height was at. It started at 4 feet, so 4. Okay. And now the 0 feet go into the equation. Okay. Again, the starting height goes right here. Okay, and the ending height is what I put into the equation for one of the variables, which is always going to be y, because that's where feet belong. Okay, so delete that and just put 0. Now you're ready to go to work. Do your steps. You got 2 answers. 0, 0, so we're set. So let's get some boxes. How many terms do we have? We have 3. Okay, so GCF. And then the t-table. It's going to be GCF DOPS if that's a 0 there, okay? Because I wouldn't need that third space. But if I have that third space, it's going to be 3. So GCF, you have a negative there always, okay? And we have x to the second, x to the first, but no x there, so we can't put x here or here. That's going to stay to the second, that's going to stay to the first. And then I let my GCF calculate 16, 30, and 4. Okay, I got 2. So again, -2. Remember, it's got to be -2. So go up and divide these all by -2. So -16 divided by -2 is 8. Stays x to the second. I take positive 30 divided by -2, that's -15. So -15, x to the first. And then positive 4 divided by -2 is -2, so -2. Okay, now forget that. And then when I do my table, it's going to be with 8, 15, and 2. Remember, keep your eye on the negatives. So I take positive 8 times -2, I got -16. So when I get a negative, that's a minus. All story problems are usually minus. So you're minusing to 15, which is negative. What's 16 minus 1? I think that's 15. So again, I didn't have to work very hard to find the two numbers. So 15 is negative, so 16 is negative. When I have a negative here, the signs are opposite. So +1 minus 16. Now your A is not 16, it's 8, okay? You got to really get out of that habit. If you look where you did the ABC, okay, that's your A. So when I make my parentheses, all 4 of them, we're going to go 8x, 8x, then +1 minus 16. Okay, so 8 and 1. The GCF's just going to be 1. Whenever 1's one of the two numbers, the GCF's 1, okay? So that's going to keep us at 8x plus 1. Okay, then 8 and 16. No, it's not 2. You got to use a calculator so you get the highest factor possible, 8. Okay, so divide us by 8, and that's 1x minus 2. Okay, remember to pull the -2 down, but do not F label it because it doesn't have an X. So the F labels come from here. Okay, so I'm going to do that out here. 8x plus 1 equals 0, or 1x minus 2 could equal 0. Okay, just do the work out there. So dot and circle, dot and circle. We minus 1. 0 minus 1 is -1, so 8 times x equals -1. Divide by 8. And then if I divide -1 by 8, I get the -0.125 again. That's not always going to be an answer, okay? It's just so happened we got it on the first two. But this one's going to be different because 0 plus 2 is 2. So 1 times x equals 2. Then divide 2 by 1, you get 2. So take your higher answer, the positive. That's your answer to the problem, 2 seconds. I still want to see both answers right there, though. Okay, 2 more. A cliff diver jumps from a ledge at 96 feet above the ocean with an initial velocity of 16 feet per second. After how many seconds does a diver hit water? So again, seconds and feet, those are the 2 units of measurement. And again, x is always the time unit, and then y is the feet. So per, feet per second. It's not 96. That doesn't say feet per second. 16 says feet per second. So 16, eliminate that. You're actually going to have 2 16s in your equation because the gravity and then the feet per second. Now, you might think initially a diver goes here. No, actually, when you cliff dive, you go up and you come back down. So again, he lands at 0 feet. Lands on the ground. But he does not jump from 0 feet because he jumps from 96 feet. Okay? So 96 is the beginning feet. Technically, that should be up higher, so just keep it consistent. So again, we need that's a parabola. Anytime we have a parabola, we need quite a bit of workspace when we're doing the work to solve the equation. So again, a parabola always has blank x to the second. Anytime you see that, you know you got x to the second. And here's the best way to set that up. Okay, so the x second, again, the force of gravity is what's pulling him back down. That's why he's not able to just go up forever. So negative 16x a second. Okay, now for the x, check here. You got 16. And here you check your beginning height, you have 96. So again, and then that 0 feet is what I put into the equation. And it's feet, it goes in for the y variable. So take this y out and replace it with 0. So that's 2 answers because you have a second power. Okay, so we're set. And we have 3 terms. Just extend the lines a little bit so the x and x squared also are on the line when I'm looking, because this would be 3 terms, so GCF. And then my table. Now you're wondering, how come on the first one you did GCF dots? Well, that's because we started from 0 here, so I didn't need that space. So that was just 2 terms. Here it's 3. So GCF, again, always get that negative there on these gravity problems. And then for x, you have x a second, you have x a first, but 96 doesn't have an x, so we're not going to put x. Okay, then I go 16, 16, 96. I got a high GCF, 16. That's okay. The higher the GCF, the better it is, because that's going to lead to little smaller numbers here, so my T-chart won't take forever. But we're not putting x with that. 96 does not have x, so we just go negative 16. So you don't always put the x in the GCF. That's only if everything has x. So that's 1, and then the x to the second stays. And then I take positive 16 divided by negative 16. That's negative 1, so minus 1. And that has x to the first. Then positive 96 divided by negative 16 is negative 6, so minus 6. Okay, remember, we want to do the ABC from here. Okay, I only do it from up here if I don't do the GCF step, but I'm always going to on these problems. Okay, so A times C. Positive 1 times negative 6, that's negative 6. So again, like I said, it's always going to be a minus. Minus needs to equal 1, and the 1 is negative. 1 and 6. 6 minus 1 is not 1, so we got to keep going. 3, so I divided by 2. I got an answer of 3. 3 minus 2 is 1. Okay, so it's those 2. Okay, 1 being negative means 3 is negative. And we have a negative product, so the signs have to be the opposite. So minus 3 plus 2. Now, a up there, a is 1x to the second, okay? So that actually makes this pretty easy. So I go 1x, 1x, and plus 2 minus 3. The GCF out of 1 and 2 is 1, okay? So if I have 1, you're just going to divide by 1, which keeps it the same. And then 1 and 3. If 1's one of the numbers you would punch in, it's going to be 1. Okay, so 1x minus 3. And again, that negative 16 is a factor, but it's not an f factor because it doesn't have the x variable. So I won't use that to solve. Here's f1, here's f2. So 1x plus 2 could equal 0. Or 1x minus 3 could equal 0. I would just do it somewhere where you have room. See, I don't have a lot of room here. So I dot and circle. So I minus 2. 0 minus 2 is negative 2. So 1 times x equals negative 2. And when you divide by 1, you're still at negative 2. So there's your first answer. Then plus 3, 1 times x equals 3. Divide by 1, and then 3 divided by 1 is 3. Now the higher answer is my real answer, 3 seconds. Okay, one more, last one. A football is thrown in the air at an initial height of 5 feet and an initial velocity of 16 feet per second. How many seconds does it hit the ground? So seconds, again, is always the answer on this assignment. So you got seconds and you have feet. So seconds would be the x, feet would be the y, and then the rate of change would be the feet per second. Okay, that is not feet per second. That is 16 again. Okay. So it lands at 0 feet. How many feet does it start at, though? Oh, 5. Okay, so 5 feet's the initial height. So I know that's going to be a T-chart problem because it's only a GCF DOPS problem if that's 0. Okay, it's not. It's 5 feet. That first problem, again, the cat was leaping from the ground. This here, the football, that's being thrown at 5 feet. Okay, you don't throw a football from the ground. Okay, so again, the parabola, I always line up blank x second plus blank x plus blank equals y. Okay, so again, why doesn't the football go up forever? Because the force of gravity pulls it down, and that's always negative 16x to the second, and then 16x, and then we started from 5 feet, so 5. Okay, so one of these letters has to go, and that's what I use the landing height for, 0 feet. So 0 feet, again, takes the place of the y. It goes in for y because y is feet. Okay, so that's 3 terms. So again, greatest common factor. And then my table. Okay, because there are sorry, I skipped some steps. You got 2 answers, you're set, so you make those boxes. Do that first before you go to the boxes. Now, my greatest common factor, again, we have a negative in front. This one's going to be a little bit weird, okay? I have x second, I have x first, and I have nothing on the 5, so I don't put x down there. Remember, x has to be on everything for you to put that. So 16, 16, and 5. So you got 1. So you put a 1 with your negative. Now some of you might be thinking, do I cross it out? No, because the GCF's not 1, it's negative 1. Okay? So I'm actually going to do this because that changes some things. Okay? You're like, well, you always cross that out before. I know, but that's when it's 1 and there's no negative. When there's a negative in front, you're going to have to do the negative 1. And when you divide by negative 1, all that really happens is the signs change. Negative 16 divided by negative 1 just makes that positive 16, and the x to the second still there. Positive 16 divided by negative 1 makes that negative 16, so I subtract 16, x to the first, Then positive 5 divided by negative 1 gives me negative 5. So I put minus 5. There we go. Okay, now A, B, C. Once again, I did the GCF because the GCF was not 1, it was negative 1. Okay, so I take positive 16 multiplied by negative 5. You always want your A to be a positive. If it's not, you're going to end up changing it positive by doing what I just did. Okay, so I get 80, which is negative. So it's negative, so it's going to be a minus. That minus needs to go to 16, which is negative. 1 and 80. 80 minus 1 is not 16. 80 divided by 2 is 40. 40 minus 2 is not 16. Okay. 80 divided by 3 is a decimal, so we can't use that. 80 divided by 4 is 20. What's 20 minus 4? 20 minus 4 is 16, so that's it. Okay, 16 is negative, so for sure. And then we have a negative product, so signs are opposite with the plus on the 4. Now, A is 16x to the second. So again, I know that's kind of a high number to put in front of your x's, but the GCF will work it out for me. Plus 4 minus 20. Okay, 16 and 4. Those are kind of 16, comma 4. I got 4, so I need to divide these by 4. So 16x divided by 4 would be 4x, and 4 divided by 4 is 1. Okay, how about 16 and 20? It's 4. Okay, that's the beauty of this calculator. So it's going to be 4x minus 5. Now, we did have our GCF here, negative 1, so I pull that down. But again, I do not use an F label for it because it doesn't contain x. Okay, the two solutions come from these factors. So 4 times x plus 1 could equal 0, or 4 times x minus 5 could equal 0. So I dot the x's. So I minus 1. 0 take away 1 is negative 1. Now, the answer is not 40. You have to divide by 4, okay? You're dividing negative 1 into 4 parts, which is a decimal, negative 0.25. That's your first answer. Okay, now on the other one, we add the 5. So 4 times x equals 5. Divide by 4. And 5 divided by 4 is 1.25. So I take my higher answer, which is the positive, and that's your answer to the problem. Now, some of you might be wondering, what if they're both negative? They shouldn't be if you do it right, okay?